Hi, and welcome to this session at AWS Summit. My name is Janos Wellach, and I'm a Developer Specialist Solutions Architect and part of the DevEx, the Developer Acceleration Team. I've been a developer for more than 20 years, and I started 2 years ago with machine learning and AI. Today, I want to show you how easy it is to enrich your serverless applications with AWS AI services. Let me start with a quote from Andrew Ng, computer scientist and global leader in AI from Stanford University. It is difficult to think of a major industry that AI will not transform. This includes healthcare, education, transportation, retail, communications, and agriculture. There are a surprisingly clear path for AI to make a big difference in all of these industries. So if we think about this, it's even more important to know how to use machine learning in our applications. With that in mind, let's go over the agenda for today. First, we will look at what AI and ML is, and then we will look at the AWS AI ML services that you can use for your projects. Finally, I will show you 2 examples on how to integrate AI ML services in your application with Amazon Personalize for recommendations and Amazon Lookout for Vision to detect manufacturing faults. Before we dive deeper into why and how, let's define the terminology so that we know we are talking about the same. AI is a way to describe any system that can replicate tasks that would usually require human intelligence. Almost always, this is related to some kind of complex decision-making where human judgment would be required. Most use cases for AI are looking for a probabilistic outcome, making a prediction or decision with a high degree of certainty, similar to human judgment. Almost all AI systems today are created using machine learning. Machine learning uses large amounts of data to create and validate decision logic, known as a model. The AI application then feeds input data into that model, and the model outputs human-like decisions. So, machine learning is the underlying technology that is powering intelligent systems. Deep learning is a type of machine learning that uses a technique known as deep neural networks. These systems replicate how the human brain functions and let AI systems address more complex use cases than before. For example, image recognition. Now that we defined the terminology, let's look why machine learning is so important for us as developers. Machine learning went to mainstream extremely fast, and for a long time, the technology was limited to a few major tech companies and hardcore academic researchers. Due to cloud computing, things began to change, and machine learning entered the mainstream. Compute power and data became more available, and machine learning is now making an impact across every industry, like finance, retail, fashion, real estate, healthcare, etc. If you look at the statistics here, the most important one for me as a developer is the one on the right. Over half of the organizations think that AI will transform their organization within the next 3 years. So, machine learning is moving to a core part of every business and industry and every application. That's why we as developers are the key of driving it. Let's have a look at how the AWS ML stack can help you. I know this might look a bit overwhelming, but don't worry, I will just give you an overview of the AWS ML stack. There are 3 layers to the machine learning stack, allowing you to start high level with a lot of abstraction and go deeper and deeper as you progress. The bottom layer is for the expert machine learning practitioner, where you directly interact with frameworks like TensorFlow, PyTorch, or MXNet. You can use our deep learning AMIs and containers and benefit from the broadest compute and GPU instances. The middle layer is Amazon SageMaker, which provides every developer and data scientist with the ability to build, train, and deploy machine learning models at scale. SageMaker removes the complexity from each of the steps of the machine learning workflow, so you can deploy your machine learning use cases more easily. The top layer represents our API-driven AI services, which you can easily integrate into your existing applications through simple API calls. The pre-trained models provide ready-made intelligence for your applications and workflows, so you can do things like personalize customer experience, forecast business metrics, translate conversations, extract meaning from documents, and more. This is the layer we want to focus on today. I picked 2 examples for today, and I want to show you a couple of code samples. But don't worry, it's very simple, and I'll walk you through how easy it is to add AI to your applications without having to worry about underlying infrastructure, frameworks, or other complexity. The first one is Amazon Personalize, to give recommendations, for example, for online retail stores. The second one is Amazon Lookout for Vision, to detect manufacturing defects. These are 2 completely different use cases, but I want to give you an idea what you can do with the AWS AI services in your application. Additionally, at the end, I want to show you one of our developer AI services which uses machine learning to optimize your code. So let's look at our first example, Amazon Personalize. Personalization is now baked into nearly every product, service, and device that we use every day. For example, in video streaming services, mobile phones, or when you order your food. Technology, and especially the combination of data and machine learning, have become the key drivers to better understand customers and deliver personalized experiences. However, customers now expecting to get a personalized experience and see this as a standard level of service. So effective personalization is no longer optional, but a requirement for business success. Delivering curated and relevant customer experiences enables organizations to improve business outcomes like acquiring and retaining customers, increasing engagement, for example, click-through rate, time on a website or app, content views or email open rate, driving efficiencies and revenue, and improving discoverability, which is particularly important for organizations with large catalogs, where new products or content is consistently being added. According to a 2019 McKinsey study, organizations that have implemented personalized recommendations and triggered communications have realized 5 to 15% increases in revenue and 10 to 30% increases in marketing spend efficiency. Amazon.com is a pioneer of personalization with over 20 years of experience. And we recognize that different personalization strategies are needed for different use cases. Machine learning has enabled us to deliver unique experiences to individual customers based on their behavior and preferences using real-time data. With Amazon Personalize, you can leverage our learnings and easily use machine learning with your data and systems and create unique experiences for your customers across channels and devices at scale. Let's take a closer look at how Amazon Personalize works. You start by providing data about your users and items to personalize. The first data type is the activity of your users, also known as events. Examples include items your users are clicking on, purchasing, or watching. The events you choose to send to personalize will be depending on your business and applications. This dataset has the strongest signal for personalization and is the only one required by Personalize. The second type of dataset includes details about your items. For example, price point, category, style, inventory status, etc. Essentially, the information already in your catalog. This dataset is optional, but very useful for scenarios such as cold starting recommendations for new items. The third dataset includes details about the users, for example, their location, age, or subscription tier. Once you have your dataset defined, it's time to get them set up and imported into Personalize. You start by creating a dataset group and then creating schema definitions for each dataset type you wish to use. From there, you can import your historical data using import jobs, or you can stream events, items, and users directly into the service. Once you have your data and personalize, you can create a custom private model, train and host it for you in just a few clicks. Behind the scenes, Amazon Personalize performs all the steps you would typically find in a machine learning pipeline, including processing and inspecting your data, identifying what features in your data are meaningful, selecting the right algorithms and parameters, training and optimizing a machine learning model, and finally, providing a real-time autoscaling API. Now that we know how Amazon Personalize works, let's have a look at a demo. After that, I show you how easy it is to do that in your own application. To demonstrate Amazon Personalize, I deployed a retail demo store. You can find this in our AWS Samples GitHub repo if you want to have a look around yourself. As you can see, I'm not signed in right now, and I'm getting some product recommendations from Personalize already. So let me just sign in quickly with my account. Once I'm signed in, I should get product recommendations according to my shopping trends. You can see here, I'm signed in as a 33-year-old male that likes tools, housewares, and apparel. And we get recommendations according to his shopping trends. This demo allows us to change the shopper, so let's switch to another shopper. Now you can see I'm getting some different recommendations according to my shopping trends. You can also click on an item here to get similar item recommendations from Personalize. That's the second showcase. Additionally, Personalize can rank items according to your shopping trends. As you can see, this is all according to my shopping trends right now. So let's switch the shopper again and choose outdoors. After refreshing the page, we will get new recommendations. And if I search something here, like a dog, for example, I'm getting personalized ranking for these items I'm searching for. So this is a very good example on how Amazon Personalize can be applied in a retail store. Now let's take a closer look at the main elements of the retail demo store architecture. The demo contains a workshop in the form of a Jupyter notebook, which creates the data set for Personalize. It also trains 3 models and creates 3 campaigns. I will explain later how this works in detail. The application components are implemented using a microservices architecture and hosted in Amazon ECS, our Elastic Container Service. Remember, in the demo, we were given recommendations according to our shopping trends. This was done through the recommendation service, which makes calls to Amazon Personalize to retrieve the recommendations. I also showed you the search feature. This search service uses Amazon Elasticsearch to rank the items in the search results. The web application is written in Vue and is loaded from a CloudFront distribution. Clickstream events are sent from the client using the AWS Amplify framework. This is how interactions are sent to Personalize to update recommendations and filters. The retail demo store is a great end-to-end example of an online store. But there are many other use cases where we just need to integrate Personalize into our Lambda function, for example. So how can we do that? Here's an overview of what we need to do in order to get recommendations in our applications. First, we need to ingest the data, and for that, we need to define a schema and a data set and import the data. Second, we need to create a solution and version to train the model. Finally, we need to create a campaign to host the model. So let's have a look how that looks like in code. A core component of how Personalize understands your data comes from the schema that is defined on the left. This configuration tells the service how to digest the data provided via CSV file or API call. Each dataset has a set of required fields, reserved keywords, and their required data types. In this example, we have interaction data. So the required fields are user ID, item ID, and timestamp. Once we have the schema created, we can call create schema and access the schema arm through the response, which we need later. After creating the schema, we need to create a dataset group and a dataset. A dataset group is the largest grouping in Personalize and will isolate your data, event trackers, solutions, and campaigns, grouping things together that share a common collection of data. The creation of the dataset group might take a short while, so please check the progress in the console or through an API call. Once the dataset group is created, we can call the create dataset API call to create a dataset for our interactions. Now we have the dataset group and dataset created, so it's time to import the data. For this, we need to create an import job. The bulk records are imported into Amazon Personalize through Amazon S3, so make sure that Personalize has the right permissions to read from your bucket. The import job will take a while, so make sure you check the progress before you continue. Now that we have the data set, we can create a solution. In Amazon Personalize, a trained model is called a solution. Each solution can have many specific versions that relate to a given volume of data when the model was trained. Amazon Personalize has several recipes that are supported. A recipe is an algorithm that has not been trained on your data yet. The user personalization recipe is optimized for all user personalization recommendation scenarios, but you can choose different recipes for your business needs. With a recipe selected, we can create the solution with the Create Solution API call. To train your model, we need to create the solution version. And after this call, the model will be trained, which takes a while. Once the solution version exists, you can obtain the metrics for it to judge its performance with Get Solution Metrics. I recommend reading the documentation to understand the metrics in detail. Now that we have a working solution version, you will need to create a campaign to use it with your applications. A campaign is a hosted solution version, an endpoint which you can query for recommendations. This is how you can call the Create Campaign API, and it will take a while to become active. So check the progress in the console or through API call. Here is a code snippet of how to call the API to check if the campaign is active. Now that we have everything set up, we can call the Get Recommendations from our serverless applications through a simple API call. So what we just did was we created the project, then imported the data and defined the schema. Then we created the solution and version and launched the campaign. This is all you need to do to start with Amazon Personalize in your application. Pretty easy, right? Now let's look at our second example, Amazon Lookout for Vision. Lookout for Vision detects product defects using computer vision to automate quality inspection. Before we look at how we can integrate this into our application, let's look at why there's a need for this. Quality impacts the cost to operations and customers. For example, in 2018, US-based manufacturers paid an estimated $26 billion in total claims. And according to Aberdeen, many organizations will have true quality-related costs as high as 15 to 25% of their sales revenue. In manufacturing, there are several types of visual inspection for quality assurance. For example, as inline inspection, you can have a manual inspection of food on a conveyor belt or machine vision during the production. You can also have the final product inspected manually. So what are the advantages and challenges with those inspections? You have agility and flexibility as advantages of manual inspections, but you have a lot of challenges with it. For example, limits in throughput, and it might be subjective to the person inspecting it. Sometimes it's incomplete and might have a slower feedback loop as well. When you replace the manual inspection with machine vision, you have the advantage that it's usually fast and repeatable and has a lower cost of inspection and a faster feedback loop. Unfortunately, those systems are usually high in upfront costs, inflexible, and have a limited coverage. So what can we do? Machine learning can help to solve those challenges, but there are also challenges to overcome, like, for example, the creation of the models. You need to have sufficient images of product defects and time to train, validate, and test the ML models. Another one is to run the models. For that, you need to consider computing and security requirements. And what about maintaining the models? They need to adapt to changes in production processes and environment at the local level. This is where Amazon Lookout for Vision comes in. You can create custom machine learning models with as few as 30 images without machine learning expertise. You can run those custom ML models in the cloud using existing machine vision and lower resolution cameras. And to improve the models, the process engineer, quality manager, and operator can provide feedback for ML models in real time. So let's have a look at an architecture for Amazon Lookout for Vision. You can see on the left side there are several options for your input images. For example, you can use a Kinesis agent to send data to the AWS cloud through Amazon Kinesis data stream and store them into Amazon S3 with Amazon Kinesis Data Firehose. Once these images are stored, you can use them to train your model in Amazon Lookout for Vision. After the training, Amazon Lookout for Vision will provide you an endpoint that you can call through the SDK or CLI to detect anomalies. Let's look at a demo of Amazon Lookout for Vision. So I deployed this Amazon Lookout for Vision demo, and you can find it in our AWS Samples GitHub repo. After logging in, the demo shows all your projects that you created in Lookout for Vision and their model versions. I have one model running here, so if I hit this, it will redirect me to a page where I can select the model again and where I can upload an image. I will just pick a normal image, and you can see it's displayed here and sent to Amazon Lookout for Vision for anomaly detection. So you can see here, this is a normal picture. You can also see the request and the response here in the drop-downs. Let's pick another image, this time with a defect. You can see here it has a soldering issue. So in this case, the model detected correctly that is an anomalous image with 81.1% probability. This demo is just a quick showcase how Amazon Lookout for Vision works. Now let's look at the architecture of the demo. The demo uses AWS Amplify in a static website to authenticate the user, and then it calls the API through Amazon API Gateway. API Gateway then forwards the request to AWS Lambda, which will use the provided image to call Amazon Lookout for Vision and returns the response to the website. So let's look how this looks like in code. First, we need to prepare the data. There are several options here. For example, you can upload the images to S3 and add labels in the console. When you want to use the API, you can specify a manifest file. This manifest file is the same that Amazon SageMaker Ground Truth uses. So if you have some labeling jobs in Ground Truth already, you can just reuse it. But it's also easy to create the Ground Truth manifest file programmatically. You can find examples in our GitHub repository. After the data preparation, we can train the model and finally deploy it. Let's have a look at each step in detail. First, we need to create a project. This is done with a simple API call. Then we define the training and test dataset with create dataset. You can see that we are referencing the ground truth manifest here. This is important as Amazon Lookout for Vision is using this information for training. Again, have a look at the documentation or at our samples on how to create such a manifest file. For training the model, we need to define the output config, so Amazon Lookout for Vision knows where to store the model after training. Then we can just call the create model API and wait until the model is trained. This will take a while, so I recommend to look at the progress in the console or through an API call. After the model is trained, we can deploy it. To do that, we just need to specify the model version that we just trained and the minimum inference unit and call the start model API. One inference unit represents 1 hour of processing and can support up to 5 transactions per second. So if you need a higher throughput, you can increase the inference units. Now we have everything set up, so we can call detect anomalies from our serverless applications through a simple API call. So you can see it's similar to Amazon Personalize. We created the project, prepared and uploaded the data, and then trained the model and deployed it. We looked at 2 examples of the many AI services and how easy we can integrate them into our existing applications. This is true for all our AI services, so you can start to integrate them now for your specific use case. But before we wrap up, I told you that I want to highlight one more service, Amazon Code Guru. Amazon Code Guru helps you to improve the quality of your code using AI. So even if you don't have a concrete use case right now for our AI services, you can utilize our AI-driven code services to improve your quality of your existing application. So what is Amazon Code Guru? Amazon Code Guru is a developer tool that provides intelligent recommendations to improve your code quality and identify the most expensive lines of code in your application. You can integrate Code Guru into your existing software development workflow to automate code reviews during application development, continuously monitor application performance in production, provide recommendations and visual clues for improving code quality and application performance, and reduce the overall costs. Let's look at how Code Guru fits into your typical software workflow. During application development, you can use Code Guru Reviewer, which uses machine learning to identify critical issues, security vulnerabilities, and hard-to-find bugs. So it improves your code quality. Code Guru Profiler detects the most expensive lines of code of your application and helps you to understand the runtime behavior of your application. So you can identify and remove code inefficiencies, improve performance, and significantly reduce compute costs. Add Amazon Code Guru now into your existing workflow to get automated code reviews and get recommendations for optimizing your application and reduce costs of your production environment. This is all from me for today, and now it's time for you to go build. Have a look at our sample repository on GitHub or take one of our courses, many available for free and on demand. You can also ask our AWS experts to help you learn to apply machine learning to your business or do the AWS Certified Machine Learning Specialty exam. Just visit the link for more information. I hope you enjoyed the session today, and I look forward to see you next time. Kindly complete the session survey and provide your valuable feedback so that we can improve the AWS Summit experience for you in the future. Thank you.